In this video, we're going to do another fairly hard radical equation. I'll show you a couple ways to do this. So, like in the last video and last example, when there's multiple radicals. So our job is to try to get rid of them one at a time at best. So, as I try to isolate one of these radicals, I'm going to go with isolating the square root of 5x plus 6. For no particular reason other than that, when I subtract 3 from both sides, I keep positive numbers. That goes away, and then I'll become a 1. Save some time and just have that rewritten right here for us. So my next step, now that I have one of the radicals by itself, I would square both sides. Squaring the left side gives me a nice and convenient 5x plus 6. Just get to drop the square root part of it. Squaring the other side is a tad more difficult. I need to put parentheses around this entire expression and then square a binomial. Now you could write this out twice and use FOIL. I'm going to use the square of a binomial pattern to make this go a little bit faster. So to square a binomial, I square the first term. Well, the first term is the square root of 3x plus 3. When I square this, it leaves me with just the inside, which is 3x plus 3. The next step is to multiply the two together, which would be 1 times the square root of 3x plus 3, so essentially they're just the same thing. Double it. There would be 2 of those if I had FOIL. So doubling it means multiplying it by 2. So 2 times the square root of 3x plus 3. And then square the second term. Well, squaring 1 gives me a 1 to tack on to the end of this. All right. I have gotten rid of one radical. I just have one radical left. Let's go ahead and try to get rid of this one. To do that, I might combine some like terms. I might add the 1 and the 3 together to have a 4. And then plus this 2 times the square root of 3x plus 3. And still got 3x out in front. And we'll just slide this down because we know it's the same thing. Then I am going to subtract the 3x and subtract the 4 from both sides. Minus 3x and minus 4. Which will give me 2x. Minus 2, actually plus 2, excuse me, is equal to, these cancel, so I'm left with 2 times the square root of 3x plus 3. So then I'm almost to the point where my radical is by itself, but I still need to get rid of this 2 that's in front of it. So to undo the multiplication of 2, I divide by 2. I'll divide this whole thing by 2. You can think of it as dividing each of these individually by 2. 2x divided by 2 will be x. 2 divided by 2 will be 1. So we have x plus 1 on the left side. On the right side, we have the square root of 3x plus 3. The radical's by itself. Let's get rid of it by squaring both sides. I square the right side. Square the left side. Now here, you got to be careful again. This is a binomial. There's 2 terms here, and we're squaring it. The right side's pretty easy. That's going to be just the radicand, which is 3x plus 3. The left side, however, again, we're squaring a binomial. Once again, that pattern is important here. Square the first term. Multiply the 2 together, double it, will give me 2x. Square the second term, plus 1. All right, at this point, we have an equation that no longer has a radical in it, which is pretty good. What we do have left is we have a quadratic equation, because it's x squared. Now to solve a quadratic equation, we start by setting it equal to 0. Subtract 3x and subtract 3 from both sides. So I have x squared minus x minus 2 is equal to 0. And then, now that it equals 0, I can use the quadratic formula or graphing or some other method. I'm going to go ahead and factor this. Most of the ones you run into will be factorable. So I need factors of x, well that's x and x. Factors of negative 2 that add up to negative 1. How about negative 2 and positive 1? So if those are my factors, my solutions would be the things that make those factors equal 0, like positive 2 and negative 1. Now, before I circle those as the answers, remember I have to check for the extraneous solution because of the odd way that square roots work. Sometimes algebraically these are okay, but way back in the beginning they don't actually work. Let's take them and plug them in both separately to see if they work. So we'll start with 2. If I plug in 2, 2 times 5 is 10. 10 plus 6 is 16, and the square root of 16 is 4. 4 plus 3 is 7. So remember that we got 7 on the left side. Plug in 2 here. 2 times 3 is 6. 6 plus 3 is 9. The square root of 9 is 3, and 3 plus 4 is also 7. So 2 works when I plug it in. Awesome. -1 is the next one to try. Here we go. If I plug in -1, -1 times 5 is -5, plus 6 is 1. The square root of 1 is 1, and 1 plus 3 is 4. So remember that we got 4 over here. Here I've got, I'm plugging in -1. -1 times 3 is -3. -3 plus 3 is 0. Square root of 0 is 0, and 0 plus 4 is 4. Look at that. 4 does equal 4. So that means -1 is also a solution. So even though I have to check it, and often when there's two answers in the end, often one of them might be extraneous, but there's no guarantee. So always check your answers when solving radical equations.